Alright, good evening. I'm Andrea Chernick, and I was put in charge of Chapter 1, Section 1 of the textbook, pages 3 through 7. Unfortunately, I do not have the textbook with me at the moment, but it should be arriving in the mail shortly. Okay, so on page 3, we have the preview of the chapter, and it basically just goes over how statistics involve variability. Key terms for this part of the chapter are descriptive statistics, which are statistics that provide tools to help organize and describe the inevitable variability among observations. These tools include graphs, tables, averages, other measurements, and then there's inferential statistics, which supply concepts that permit the observer to generalize beyond limits set for observations, and these are considered the more advanced statistic methods. So page 4 asks why study statistics. And essentially it's saying it's crucial for us to understand statistics when it comes to research reports, especially when looking at results and conclusions, as well as conducting and supporting your own research. On page 5, it goes over what is statistics. Again, it accounts for variability, and there are descriptive as well as inferential statistics. Then we have a progress check, asking to identify descriptive and differential statistics. The first one, students in my statistics class are on average 23 years old, and that would be considered descriptive because it's looking at the average. The population of the world exceeds 7 billion, that's a generalization, so that would be inferential. Either 4 or 8 years have been the most frequent terms of office actually served by U.S. presidents would be a descriptive statistic. And D, 64% of all college students favor the right to abortion laws is inferential. And on page 6, we have more about inferential statistics, and we focus on population versus sample. A population is any complete collection of observations or potential observations, and a sample is any smaller collection of actual observations drawn from a population. Notice in this section that populations are viewed abstractly and more as like a collection of measurements. And it really depends on your perspective how you want to classify something as a population or a sample. Populations are usually large and potential observations are accumulated, while on the other hand samples are usually small and record actual observations. Then on page 7 we get into random sampling and surveys. The sample should be selected at random from a population in order to increase the likelihood that the sample accurately represents the population. And random sampling is a procedure designed to ensure that each potential observation in the population has an equal chance of being selected in a survey, for example, playing the lottery. It's really difficult to obtain information when a population lacks structure or specific boundaries, and often then people have to guess and make estimates, so any resulting generalizations could be debatable. And that's it.